Now for the next question, which is question number 8. Question number 8 says a cube has a volume. Cube has a volume of 1000 centimeter cube. Calculate the surface area of a cube. Okay, first we will understand the shape. You are all familiar with the shape of a cube, which is having same sides, length same sides, and height also same. So this one I have drawn cube for you. So each side is 10 into 10 into 10. So it means it is 1000 centimeter cube. So each side of this cube is 10 centimeter. Length, width also 10 centimeter, and height also 10 centimeter. So we got this cube which is having all sides 10 centimeter. So now formula for surface area of a cube is equal to 6 into side square, s square. So s in this case is 10. So we'll replace the value of s. So we will get 6 into 10 square. Always replace values in brackets. So we will get 6 into 10 square will be 100. So this will be equal to 600. So its surface area, so it will be centimeter squares. At the answer they have already provided centimeter squares, so you will have to just mention 600. So this will be your surface area for this cube. Question 21. The radius of sphere is 5.2 centimeter. Work out surface area of the sphere. They have given formula for area of a sphere with radius r. So just we will have to replace the value. A is equal to 4 pi r square. So r we have 5.2. So 5.2 square we will use calculator, and if we replace these values, 4 pi into 5.2 square will be equal to 339.79, which is approximately equal to 340 centimeter. Units are centimeter, so we'll write centimeter square. So it will be 340. Question number 8. Diagram is provided. Triangle ABC is isosceles. AC is parallel to BD. AC is parallel to BD. Find the value of A and B. If you check this triangle ABC, this triangle is isosceles triangle. Isosceles triangle means it's having two sides equal. This side is equal to this side. So opposite angles will be equal. Opposite angle of this side is A, and opposite angle of this side is this one. So these two angles will be equal to each other. As the total angle of interior angle of this triangle is 180, so 180 minus 40 degree, this 40 degree, 180 minus 40 degree will be equal to 140 degree, which is these two angles. 140 degree is divided into two equal portions, and this angle and this angle will be equal to 140. So we'll divide this 140 by 2 and we will get 70 degree. So this angle A is equal to 70 degree. Angle A is equal to 70 degree. Now in this triangle, we know AC is parallel to BD, hence this angle C will be equal to this angle B. As C is 40, so B will also be 40. So we will write here 40 degrees. Question number 10, A part. Show that the volume of a metal sphere of radius 15 centimeter is this one. Correct to 4 significant figures. The volume V of the sphere with radius R is, formula is provided for the volume. We'll have to just replace the values in this formula. So V will be equal to 4 over 3 pi. R is provided. R is 15 centimeters, so 15 cube. If we calculate, our answer will be 14140 centimeter cube. This is done. Now B part, B1. The sphere is placed inside an empty cylinder. Cylindrical tank of radius 25 centimeter and height is 60 centimeter. The tank is filled with water. Now this is the tank, 25 centimeter radius, is 60 centimeter height. Calculate the volume of water needed to fill the tank. So sphere will not be allowing water to occupy space, so we'll have to find the volume of this cylinder with radius 25, height 60, and we'll have to subtract the volume of sphere which we calculated earlier, 14140. So the volume of cylinder will be pi r square into h. So volume will be equal to pi r square, pi into 25 square, pi into 25 square, which is radius square, into h, which is 60, and from this one we'll have to subtract minus 14140, which is the volume of the cylinder, which we have already calculated. So if we use the calculator, our answer will be 104,000 centimeter cube. So we will write the answer at the specific place. So this will be, answer will be 104,000 centimeter cube. Part 2, the sphere is removed from the tank. Now this is removed, sphere is removed. This is the only water in the tank. Calculate the depth d of water in the tank. So depth we have to calculate. For calculating depth, we will be using the formula. Basically we'll have to subtract from this volume. This is the volume of water with sphere. So this is volume of water without sphere. So volume of water without sphere, if we find the volume of this one, pi r square, pi r square will be the r is 25, so pi into 25 square into d multiply by d should be equal to 104,000. So we can calculate the value of d, which will be 104,000 divided by pi into 25 square. So this will be equal to 52.75, which we can round, and this is centimeters, so we can round it to 52.8. Three significant figures. Part C, the diagram below shows a solid circular cone and a solid sphere. Both are solid. So the cone has radius 5 centimeter. This is the radius, and height is 12x. 5x radius and 12x height. And keep in mind this height is perpendicular height. The sphere has radius r. This is the radius r. The cone has the same total surface area as the sphere. Show that this is equal to this. And total surface area, you should keep in mind, total surface area is curved surface area plus the base also. So because this is solid, so curved surface area plus the base area will be the total surface area of this solid cone. Now we will find first, for example, this one what we call solid sphere. Solid sphere will be pi r square. It's this one, yeah. So formulas are provided. The curved surface area of a cone with radius r and slant height. Keep in mind this is slant height. L is a into pi r l. This one we will use for curved surface area of cone, and this will be the surface area of the sphere. This will be the formula. So area will be pi r square for this sphere. 4 pi r square is for this sphere, and total surface area of this cone we will calculate, which is pi r square, which is base, pi into r square, which is 5x square, plus we need to find the curved surface area of this one. To find the curved surface area, we need to find the slanting height, and for slanting height we have to check this one. So if we draw this triangle like this one, so this height is 12 and this height is 5, so we have to find this hypotenuse. We'll apply the Pythagoras theorem because this is right angle triangle. So this will be 12 square, we can solve here, 12 square plus 5, 12x basically, this is 12x square plus 5x square, this square will be for whole, under root by Pythagoras theorem, these two sides square will be equal to this side. So this will be curved surface area of this one. So this will be 12 plus 12. Basically, if we write this one, 12 square will be 144. 144x square plus 25x square root. So this will be 169x square under root, which will be equal to 13x. So 13x will be this slanting height, So we'll have to include, we'll have to use slanting height L. This is our L, so we can find this L, we can write here L. So area will be this base, which is pi r square, plus pi r L, pi into r, which is 5x. So 5x multiplied by 13x. So now we can write 4 pi r square is equal to, this will be 25 pi x square, plus this will be 65 pi x square. So this will be 4 pi r square, 4 pi r square, we can write here 4 pi r square is equal to, we can add this one to 90, 25 plus 65 will be 90 pi x square. So pi can be cancelled from both sides, so x square, we can find r square. Basically we have to find r square, so r square will be equal to 90x square over 4, which is equal to r square. So we can cancel this, 2 2 are 4 and 45. So r square will be equal to, r square will be equal to 45 over 2x square. This will be our final answer. Question number 9. The diagram is provided. The diagram shows a trapezium ABCD. AB is parallel to DC. AB is equal to 55 meters. BD is equal to 70 meters. And angle ABD is 40 degree. And angle BCD is provided as 32. So these angles are provided and two lengths are also provided. Calculate AD. We have to calculate AD. This is our required length. So these two sides of this shaded triangle, this one is the triangle which I am shading. For this triangle, these two sides are given, plus included angle is given, which is the condition for cosine rule. So we'll be using cosine rule to find the length of this one, of this side. So we can write this side square 55 square plus this side square, which is 70 square, minus 2 into 55 into 70 cos of the included angle, which is 40, so cos of 40 degree. So now we will replace this in our calculator and we will get the value, which is 45. So this will be resulting to 45. So our this side is 45 meters. So we write 45 meter in the space provided. We can write the answer as 45. So we'll write 45 over here. Then for part B, we'll have to calculate BC. If we see BC is this side, so we'll have to calculate this side. For this one, we have to understand, see this one AB is parallel to DC. So a line intersecting, this is DB, which is line intersecting these two parallel lines. Hence this angle will be equal to this angle. So if this is 40, this will also be 40 degrees. Now we have two angles and one side, so we can use sine rule in this case, and we need this length, so this side we will be using, and which is BC over 40 will be equal to 70 over 32. So I will write down in the space provided as BC over sine of 40 degree will be equal to 70, which is dB, 70 over sine of 32. So this implies BC will be equal to 70 multiplied by sine 40 over sine 32 degrees. If we replace these values in our calculator, we will get 84.9. So our answer will be 84.9. This will be in meters. So we can write down the answer as 84.9 meter is already written. Part C, calculate the area of ABCD. If you check the drawing provided, this was the provided drawing ABCD. So we can split this drawing into two triangles. One is the shaded one, the other one is unshaded one. For shaded one, we will apply sine formula for area of a triangle, and this will be these two lengths and sine of this included angle, and then we will apply sine rule for the unshaded triangle one by one. So I will keep triangle over here. So I will write down for the shaded triangle. So it will be 1 by 2 and multiply by 55, which is one side, and the other side is 70, and multiply by sine included angle is 40, so sine 40 plus area of the other triangle, which is DBC. So sides are we'll write 1 by 2 into first side, one side which is 70, multiply by the other side which we have calculated 84.9, and it will be multiplied by sine of included angle, and sine of included angle we can calculate the sine of included angle. This is 40, this one is 32, which is 72, so this included angle will be 108. So we'll take sine of 108 here, so this will be 108 degrees. So this is how you can see this is area of this shaded triangle, and this is area of this unshaded triangle, and we have added these two areas to find the area of this trapezium. So now we will use calculator to find the value of this one. So if you use calculator, you will get the value which is 40 point. If we insert all these values, so area will be equal to 4063.26, and we can round it to 4063 meters square. This will be our answer. Part D, calculate the shortest distance from A to BD. Again, we'll refer to the diagram provided. A to BD. A is this one and BD is this one. So shortest distance. So if we draw, shortest distance will be the perpendicular on this line BD. So this will be the shortest distance. Now this is our right angle triangle, and we have to find this. For example, if we take this point as for example F, So AF length we have to find, this shortest distance, and in this triangle we are provided with this angle which is 40 degree. So this is our perpendicular and this is hypotenuse. Perpendicular over hypotenuse will be sine of 40 degree. So I will use sine of 40 degree. So this one, in triangle AFB we will take sine perpendicular over hypotenuse, which is sine of 40 degree. So I will write down sine of 40 degree will be equal to shortest distance, which is AF, which is required, over 55. So distance AF will be equal to 55 sine 40 degree. 55 sine 50 degree will be 35 point. If we check with the calculator, we will get 35.35, or we can write 35.4. So our answer will be 35.4 meters, because lengths are in meters. Meter is already mentioned, so no need to mention this meter, it's already mentioned. So I will write 35.4. We can mention here meters.